हेलो।
हेलो।
हाँ, सुनाई दे रहा है ठीक सर?
हाँ हाँ, ठीक है।
ठीक है। सो हमने वो पहले एनालिटिकल टेक्स्ट में क्या पढ़ा था? इलेक्ट्रॉन माइक्रोस्कोप के बारे में पढ़ रहे थे। तो इलेक्ट्रॉन माइक्रोस्कोप आर टू टाइप्स ऑफ इलेक्ट्रॉन माइक्रोस्कोप आर देयर। सो व्हाट आर दिस? कुछ याद है?
एक तो था नाम याद नहीं आ रहा था मुझे।
स्क्रीन दिखाई दिया?
हाँ, स्क्रीन दिखाई दे रहा
हाँ। So electron microscopes are somehow it is better than ordinary microscope. That is called electron microscope. So this electron microscope are again two types. Here this is the basic structure of electron microscope we already discussed. In ordinary microscope what happen? The light can be passed through the lens and it can be fall on the object and we can able to see magnify image up to maximum 100x 200x like that. But in electron microscope we are not just entering the light, we are bombarding some beam of electron from the electron gun, and that electron are just fall on the sample and pass. By passing the sample they can detect with the image laser detector. Here the here the electron is passed through here and fall on the plate where the sample is kept, and again it will fall on the detector, so we can see the magnified images that may be 10,000x. So the electron microscope are again two type. What are these? Are these two types? These are the different uses where electron microscope can be used: nanotechnology, forensik, mining, all the things. So even if it is very largely used, electron microscope having some disadvantages, and this is the parts of the electron microscope. These are already discussed: source, lens, and that are lens are two types again: condenser lens, objective lens, then the projector film, and the specimen. So one type is called scanning electron microscope and another type is called transmission electron microscope. So we have just covered the scanning electron microscope, what it is mean. Scanning electron microscope, at its name is scanning. What happened? The electron ray that can scan the object or scan the specimen and generate a large image of that by passing this electron. This is called scanning electron microscope, and this is better than the ordinary microscope. So this is the instrument, scanning electron microscope, where this is a very sophisticated instrument and the cost of instrument also very high, and you can see the images of electron proton, images of the molecular level. These are there are different parts are there, that electron gun, condenser lens, primary a condenser, then specimen holder, and lastly detector. Already discussed that. These are some examples how we can prepare the sample and how we can see the electron microscope under the electron microscope. So that may be 100,000x magnification and 1000x in the ordinary microscope. So this is the difference how we can see the large images. If this is the structure of the cell, so these are already discussed. See, this one of the molecular structure. One example here in below you can see the scale is given here. What is the scale? This scale is this image is taken up to 500 nanometer. So this is the range 500 nanometer. We can see the images. So there are different range that depends on how we can analyze these images. This is one another example. This is another example. See, this is how we can see. So just advantages of the scanning electron microscope, we can use as energy dispersive X-ray microanalysis. This can be done by these X-ray techniques with the electron microscope. So implementing this electron on the sample, we can analyze not only analyze the image, also analyze the elemental detection, how much the element can be present in these particular images. See, this is the example of EDEX analysis. There are two structures are there. This structure is image. Here we can see the pattern. Next, this is called the elemental analysis or the EDEX. So this here we can all both can be derived the electron sorry images and as well as the elemental analysis. If the peak is maximum, that can we can say that here aluminum is the most common element that can present in the sample. So there are disadvantages also same. So due to this different kinds of the disadvantages, we are again moved to more advanced technique that is called these are examples, because only black and white color can be seen in same, but these examples these are the we can and color or we can photoshop this into the color in order to enhance the quality in order to describe the images. Let's move forward. Then in order to overcome the limitation of SEM, that is scanning electron microscope, the next advanced version of the electron microscope is called transmission electron microscope. So this is the highest sophisticated instrument that is also overcome the difficulties that arises in the SEM. So this is called TEM, TEM. So the beam of highly focused electron are directed toward the thin film of sample, and normally no scanning required in order to hide the resolutions. In SEM, what happen? Total entire sample should be scanned by the electron gun, but here there is no scanning required. Only the rays that can be passed through the thin film. So this is the techniques used in the TEM. That is why it's called transmission electron microscope. That means the thin object here it is taken precious precaution that the sample which is prepared is very in a thin film, and that can be placed in a transparent glass, and the electron beam are passed through this thin film of the sample. So the amount of electron that transmitted towards the detector, by analyzing this we can see the images of the sample. So here also the instrumental parts are same: electron gun, then condenser lens, then objective lens, then projector lens, and then detector, finally detector. This is the instrument that is for TEM. The cost of the instrument is also very much high, and no here the chance of error is very less, and we can see very clear images and the clear overcome the all the defect that can be arises in the same. So transmitter electron microscope is used for characterization of material as well as crystal structure and microstructure simultaneously by diffraction and imaging technique. Here, as the electron are passed through the sample, we are use diffraction and imaging technique. What is diffraction? Sorry, refraction is the reflect back, that is the reflection. Refraction means when the light pass from one medium to another medium, and diffraction means when the light falls and the on any surface, and the surface having so many groups are there, so light can be travel here and there, not a single direction. So this is called diffraction or simple diffusion of light. So this use this diffusion or diffraction technique, we are going to see the images or enhance the images, so by applying the images technique. So electrons scatter when they pass through the thin section of specimen. Scattering, diffraction, all the physics term, and simply when the electron are passed, the electron are nothing but a high energy sources and a high beam of light also. So when this fall into the specimen plate is designed on such a way that the light can be dispersed in a different way, as well as it can scatter. Scatter means it can be diffused into sudden atmosphere, or when it pass through the specimen, it can light can be diffused. So amount of the diffusion that can be taken concentration into seeing the images. So denser region of specimen scatter more electron than darker. If whenever you light is pass through the specimen, somehow if there are in back side there images can be fault. If the specimen is dark, then light is scatter more, and whenever light is not scatter, that it can be have a lighter region. So transmitted electron also do not scatter, so you the produce image. Simple thing, it is called as transmitted electron microscope. Like just in previous days हम लोग देखते थे ना, जो इमेज को एनहांस करने के लिए एक नेगेटिव फिल्म आता था, उसके ऊपर हम लाइट डालते थे और पिक्चर आता था, दीवार में दिखता था. तो सेम एप्लीकेशन, सेम काइंड्स ऑफ थिंग इज हियर. सो व्हाट इज एडवांटेजेस? टेम ऑफर्स द मोस्ट पावरफुल मैग्निफिकेशन. जितना भी इलेक्ट्रॉन माइक्रोस्कोप है, सबसे एडवांस वर्जन है टेम, एंड पोटेंशियली ओवर मिलियन ऑफ टाइम्स मोर. Even million times more enhanced image can be seen here. Direct imaging and crystalline lattice. Here we can see the crystalline pattern of the sample. No metallic stain coating needed. Like in SAM, the sample is prepared, the sample preparations taken by so many carefully and so many precious precautions taken to prepare the sample. But here no metal coating, all the things are required. Just prepare the slides. That can be very thin film can be prepared. Images are high quality and detailed. Electrons can only travel in a vacuum, so the specimen must be completely dehydrated. If the sample get some contaminated or some water vapor, or it can be hygroscopic, then the images cannot be clearly seen. So the sample must be dehydrated. All water molecule or any other contaminant must be removed. So electrons have poor penetrating ability, which the images contrast result when electrons are scattered by the specimen. So therefore specimen are usually stained with a coat of heavy metal, uranium, osmium, all these things. In order to enhance the ability to transmit electron or scatter the electron, we may use some different stain for which that can be enhance the images. What are the disadvantages? This instrument is very large and very expensive. It normally cost very high expense, that is 50 lakhs to 1 crore rupees for instrument. So images are black and white, no color images can be takes place. We can later we can enhance by Photoshop, with Photoshop to color images. And preparation is limited to electron transparent sample due to conductivity to electron density and sample thickness. Where we can this is limited, or we can take limited images of the sample when only when the sample is can be sliced into thin film. If the sample cannot be sliced into thin film, we cannot take images for that type of sample. So this is a limitation also for this TEM. Nowadays what happened, there are more sophisticated instrument, advanced instrument of from the TEM also now arrived, and this is that may be overcome all the disadvantage of the TEM. And this is one example of this STEM images. Here one left side is bright field and right side is dark field. It like a negative. जो पहले जो पुराना फोटो आता था, फिल्म आता था ना, ब्लैक एंड व्हाइट नेगेटिव फिल्म, ये ऐसा ही दिखता है. ब्लैक दिखा मतलब वो डार्क फील्ड, सॉरी ब्राइट फील्ड है, और व्हाइट दिखा मतलब दैट इज डार्क इमेजेस है. उल्टा ही. This is also then comparison of transmission and scanning microscope. TEM and SEM. What is the difference between TEM and SEM? TEM advanced version है SEM से. So then SEM are also having quite larger images and having enhanced capacity. A 5 kb SEM, 20 kb SEM, 200 kb SEM. We can see the magnifying the range. Then electron range increases with beam energy, and the internal structure of the some deposits also electron energy is SEM and TEM, which are very much clearly visible with the TEM, and some are not clearly visible with the SEM images. So this is the difference how matter interact or sample interact with the electron. Left side is SEM and right side is TEM. See here, the electron are fall on the sample, and some electrons that can be reflected back, and we can detect the reflected electrons. This is same. But transmitted electron, where the sample is preparing a thin film and the same electron that can pass through the sample and we can detect the sample. This is the detector or eye. This is the detector eye. This is the difference between this SEM and TEM. So electron beam is focused, scanned over the sample in case of SEM. Secondary electron are backscatter electron, and that are characteristics of the X-ray point of interaction. That's why you also know the amount of the analysis. That is also advantage of SEM. Where in SEM we can detect the amount of the element which is present. That is called EX or D. And 2D images of the spectral distribution also in mapped in case of SEM. And TEM, the electron beam is passed through this sample, and we can give more resolutions and more enhanced images than SEM. So there are obviously SEM, TEM, all these things. These are all called electron microscope, and these electron microscopes having some disadvantages. It is very larger, expensive, and also destructive technique. Destructive techniques does mean the sample that can be used is cannot be regenerated. Once the sample is used, the sample cannot be used in other techniques. So the sample is destroyed uh, in this technique. So some material are sensitive to electron radiation and loss of the crystallinity, because if the some of these sample which are very much reactive or very much sensitive samples are there, so in that case when the electron beam that can be touched with the sample, then it can react, or we can change its crystallinity, it can change its directions, it can, we can see the distracted images. So the originality of the ordinary images of the sample is lost in case of this electron microscope. Sample may have damage by the electron beam, obviously. Field view of the small region analysis is not a characteristic of whole sample, because we are analyzing in a very nanoscale range, but in a large view it cannot be same, we cannot be compared to small to a very large sample. Sample preparation is also very much crucial here. So carefully you have to prepare the sample. If the sample preparation is wrong, then whole images can be wrong and we cannot actually visualize the sample. These are the disadvantages of the electron microscope. So in order to overcome these disadvantages, there are some other techniques are there. So this is another technique. This is actually not in your course, but just know for your knowledge, that is called confocal microscopy or confocal scanning laser microscope, CSLM. So these are the again highly sophisticated instrument, and here we are using laser scanning confocal microscopy. That means the laser, we are using the laser rays instead of the electron gun or electron beam, so that can be overcome some of the problems of the electron microscope. So this basic concept of the laser confocal microscope is derived by this Marvin Minsky in 1950, and this is also very much used in particular sophisticated instrument. Here we can see by some biological applications, this sample can be used for the determines the brain tissue, all these things, thickness of the layer. This can be used by this uh, advantages of this. What is the advantage of this laser techniques? This microscopy offers several advantages over other microscopy, and ability to control the depth, illumination, background, plane, all the things, and also the optical section of the specimen. Also, here the specimen, however may be thick, we can determine the thickness also, and this is also a greater advantage over the optical microscope and electron microscope. So the other difference between this electron microscope, the SEM and TEM, this is a very much important questions. Just what is the difference between SEM and TEM? Here, in case of TEM, electron beam is transmitted. In case of SEM, electron beam is scanning, and it can be detected by reflecting back. Here, SEM section is required for the microscopy. Here, there is only surfaces is stained by some chemicals. Here in TEM, the most common form of electron microscope has the best resolution. It is better than SEM. And in the SEM, whatever it is maybe, so it is less effective than TEM. So this is the some difference, three four difference between the SAM and TEM, and it is the one of the important question that maybe comes in your exam. Also, what is the difference between the optical microscope and electron microscope? This is also one some simple questions. Optical microscope is cheap, electron microscope is expensive, it is small, it is large, it is good, it is bad, like this thing. So this is all about your electron microscope, SAM, TEM. So disadvantages obviously large, expensive, destructive, all these things. This is all about SAM and TEM. एनीथिंग कुछ पूछना है सैम एंड टाइम बारे में?
नहीं सर।
ठीक है, तो अभी हम आगे बढ़ते हैं. नेक्स्ट टेक्निक इज कॉल immunological techniques. Actually these techniques are somehow different. These are some tests, or these are used in some what call it is biological test or some human based test. These are quite different, fully different from the same time or all these spectroscopy techniques. These are particularly some test which is called immunological techniques. What is immune system? We already heard the name immuno. कोई किसका इम्यूनो ज्यादा अच्छा है होता है, उसको ज्यादा बीमारी नहीं होता, इस टाइप का जो है उसमें हमको पहचानना पड़ता है किसका इम्यूनिटी कितना है. दैट इज यूज्ड एज इम्यूनोलॉजिकल टेक्निक्स. So immunologic test use an antigen to detect antibody or pathogen, that use antibody to detect antigen or pathogen. That means there are some antigens are there or some antibodies are there. आपको पता है एंटीजन एंटीबॉडी किसको बोलते हैं? बायोलॉजी थोड़ा सा पढ़े होंगे तो याद होगा. एंटीजन, एंटीबॉडी, पैथोजन, ये सारे बैक्टीरिया, कंटामिनेशन, वायरस, ये सब आता है इसमें.
ओके सर.
एग्जाम्पल लेते हैं एक. एंटीजन किसको बोलते हैं, एंटीबॉडी किसको बोलते हैं? अभी जैसे कि डेंगू हुआ था मुझे, ठीक है, तो किसी को भी डेंगू हो गया मान लो, तो पहले से कभी नहीं हुआ और किसी आदमी को डेंगू हो रहा है, तो उसमें डेंगू इज द फॉरेन सब्सटेंस और एलियन बॉडी फॉर आवर ओन सिस्टम. पहले जो भी फॉरेन वायरस हमारा बॉडी में एंटर कर रहा है, दैट इज एलियन फॉर आवर बॉडी. So what happen if the alien system is trying to attack you, your body have own defense mechanism against this foreign alien. So जैसे ही डेंगू वायरस शरीर में घुसने की कोशिश किया, तो हमारा जो बॉडी में क्या होता है, उसके लिए डिफेंस सिस्टम एक्टिवेट हो जाता है. So that defense or the army of our own body, that is called antibody, and the alien foreign substance, that is called antigen. So एंटीजन उसका अगेंस्ट में हम लोग काम करते हैं, हमारा बॉडी जो बनाता है, दैट इज कॉल्ड एंटीबॉडी. सो एंटीजन और एंटीबॉडी के बीच में लड़ाई होता है, जो जीता वही सिकंदर है. मान लो एंटीजन जीत गया तो डेंगू आपको आज हो जाएगा बुखार, और एंटीबॉडी जीत गया तो आपको बुखार नहीं होगा, इवन इफ द वायरस और बैक्टीरिया दैट कैन बी अटैक. तो जैसे ही हमको बुखार आ रहा है, दैट मीन्स आवर एंटीबॉडी और आवर इम्यून सिस्टम बिकम डाउन. दैट्स व्हाई वी आर having some fevers or having some trouble. So in order to test which type of malaria है, डेंगू है, टाइफाइड है, ये लोग हम लोग क्लिनिकल टेस्ट होता है, ये सब क्या करते हैं, पहले एंटीजन और एंटीबॉडी टेस्ट होता है हमारा जो, तो पता चलता है कि ठीक है, इसका ये वायरस अटैक हो रहा है. सो दिस टेस्ट इज कॉल्ड इम्यूनोलॉजिकल टेस्ट. टेस्ट of the specimen, patient specimen, particularly that may be blood हो गया, यूरिन हो गया, प्लाज्मा हो गया, कुछ भी हो गया, and that specimen, that is called sample, that can be test against both antigen as antibody. कितना एंटीजन है वो भी टेस्ट हो सकता है, कितना एंटीबॉडी है वो भी टेस्ट हो सकता है. So this type of test is called immunological test. In order to know the immunity system, what is the defense mechanism is how much active, so we can take some pills or some drugs that can be enhance our antibody to fight against antigen. One of the test is called agglutination test, agglutination test, and this agglutination test is like latest agglutinations and co-aggregation. That is, a particle latex-based bacterium is coupled with reagent, antigen, antibody, so resulting the particle with the specimen. This is some technical term that is mostly related to the clinical laboratories. Just with the remember the name only, एग्लूटिनेशन टेस्ट। एग्लूटिनेशन उसका मीनिंग ये है कि एग्लोमरेशन मतलब क्लॉटिंग, जैसे कि ब्लड क्लॉट हो गया, फ्लो हो रहा था, फुला था, कट वो क्लॉट हो गया तो जाम हो गया, जैसे सेम टाइप ऑफ whenever we are test with this our sample with some kinds of latex based uh, uh, that stain, then what happen, how it react with the clotting, or how it react, or how it can form agglutination, that is test done by called एग्लूटिशन टेस्ट। ये उसका एग्लू पॉजिटिव है क्या नेगेटिव है, ये देखो इसमें लेफ्ट साइड में ये एक साथ में एक हो गया, क्या हो गया, ये एक जगह पे क्लॉट हो गया, दैट मींस एग्लोमरेशन हो गया, तो हम पॉजिटिव बोलेंगे। जब ये नेगेटिव है तो एग्लोमरेशन नहीं होगा, क्लियरली दिख रहा है। दिस इज कॉल्ड एग्लूटिशन टेस्ट। नेक्स्ट टेस्ट इज कॉल्ड कॉम्प्लीमेंट फिक्सेशन। What is it? The test also measure complement consuming or complement fixing antibody of the serum. That test is also diagnosis of some viral or fungal infection. जैसे कि ये कुछ complement consuming और complement fixation antibody रहता है। That means whenever there is a bacteria or viruses are attack your body, then our body system is designed in such a way that types of antigen can kill particular type of the antibody। मान लो एक साथ में आपको मलेरिया हो रहा है तो हमारा बॉडी में जो एंटीबॉडी बनेगा वो सिर्फ मलेरिया को मारने के लिए बनेगा, ना कि सेम एंटीबॉडी कैन नॉट डिफीट विद अनदर टाइप ऑफ वायरस। सो ये होता है कॉम्प्लीमेंट फिक्सिंग, मतलब जिसका ताला है उसके चाबी ही खुलेगा वो, और दूसरे में कुछ भी काम नहीं आने वाला। So that can be tested by the complement fixation, and this is also test for the different clinical laboratories. Next is enzyme immunosynthesis। एंजाइम भी एक टाइप्स ऑफ हमारा बॉडी में होता है, एंड दैट कैन बी रेगुलेट डिफरेंट काइंड्स ऑफ मैकेनिज्म इन आवर बॉडी। सो दिस टेस्ट यूजेस एंटीबॉडी लिंक एंजाइम टू डिटेक्ट एंटीजन। एक्चुअली क्या होता है, एंजाइम इज ए टाइप ऑफ केमिकल्स that can be activated with certain region or certain types of causes। मान लो आपको बुखार आ रहा है तो आपका बॉडी में एक डिफरेंट एंजाइम क्रिएट होगा, आपको बहुत ज्यादा भूख लग रहा है तो दूसरा एंजाइम क्रिएट होगा, आपको कुछ अटैक हुआ है, कहीं चोट लगा है तो दूसरा एंजाइम क्रिएट होगा। तो ये जो एंजाइम है, ये एंजाइम भी पार्टिकुलर स्पेसिफिक होता है, एंटीजन स्पेसिफिक होता है। सो वी कैन ऑल्सो टेस्ट दिस एंजाइम। The most example of the enzyme is called enzyme immunoassay, that is called EIA, and most example is called enzyme linked immunosorbent assay, ELISA। Just remember that name, enzyme linked immunosorbent assay, ELISA, and this test is mostly done for the एड्स वायरस। इसको एड्स हुआ है नहीं हुआ है टेस्ट करने के लिए particular this ELISA test ही होता है। This is the one single test that can be determine whether AIDS virus is enter in your body or not। एड्स के लिए ये टेस्ट होता है एल्सा। तो ये पार्टिकुलर सम टेस्ट है, दिस इज वेरी मच particular or case specific। Then test is sensitive although it is very high and sometimes according to patient age, material, all these things, ये डिपेंड करता है कितना डिजीज है, आपका बॉडी का इम्यून सिस्टम क्या है, वो सारे ऊपर कितना एज है। सो जस्ट एग्जांपल, रिमेंबर दिस एग्जांपल ELISA that can be used for the AIDS virus। ये उसका टेक्निक्स दिया हुआ है कैसे करते हैं, दिस इज नॉट रिक्वायर्ड, उनको जरूरत नहीं है जानना। देन लास्ट टाइप ऑफ इम्यूनोलॉजिकल टेस्ट इज कॉल्ड प्रेसिपिटेशन टेस्ट। Precipitation is the common term used in chemistry whenever there is some precipitation, that means जैसे कि हम लोग दही में सॉरी दूध में नींबू डाल देंगे गर्म करने के बाद तो जो क्या बनता है, हमारा छेना बन जाता है, जो उसको बोलते हैं पनीर बन जाता है, तो वो होता है precipitation। like this, whenever the antigen antibody or fluids are visible in the precipitation test, then we can also add some solution to form a gel-like structure or solution, then we can count the number and that is called precipitation tips. जैसे कि ब्लड क्लॉटिंग हो गया, ब्लड ग्रुप जैसे होता है, इसका टेस्ट करते हैं, एक स्टैन देते हैं, उसमें टेस्ट करते हैं, तो उसी टाइप का एक टेस्ट है, दैट इज कॉल्ड प्रेसिपिटेशन टेस्ट. This is all about 4 tests, that is immunologic test, and some techniques that are called also radioisotopic technique. These also different techniques, and this is not normally used in our chemistry or environmental things. These are for clinical based laboratory techniques. So radioisotopic technique use some radioisotope to detect its presence or some its reaction with our sample. So what is radioisotope? Radioisotopes are the radioactivity element that spontaneously emitted alpha beta gamma rays. आइडिया है ना रेडियोएक्टिविटी क्या होता है थोड़ा बहुत? अल्फा रेस, बीटा रेस, गामा रेस, दीज आर, जैसे कि आपको रेडियम हो गया, हिल क्या बोलते हैं इसको, प्लूटोनियम, रेडियम, थोरियम, जो न्यूक्लियर रिएक्टर में यूज होता है, दैट आर कॉल्ड रेडियो आइसोटोप, रेडियो एलिमेंट. बट there are some different elements which are radioisotope in our common environment also. See what is radioisotope? Radioisotopes are one or two or more atom having same atomic number but different masses. For example, what is the atomic number of carbon? Carbon atomic number is 6, and what is the atomic masses of carbon? That is 12. C12 is the one isotope, and C13 भी होता है, C14 भी होता है. So these having same atomic number but the masses are different due to presence of extra neutron atom at that center of nucleus. So these radioisotopes, these are called radioisotopes, and these radioisotope molecules are very much unstable, and they are having some specific self life in the atmosphere or in the some reagent. So these are called half life or lifetime period. So these unstable isotopes are called radioisotopes, and these having half life or some decay, or that is called radioactive decay. So what is decay? Decay means it can able to emit spontaneous kinds of emission in order to stable, because जो उसमें ज्यादा प्रोटॉन है, ये ना क्या बोलते हैं, न्यूट्रॉन है, तो वो अनस्टेबल होता है, तो हमेशा वो चाहता है कि स्टेबल स्टेट में आए. So why we are use that radioisotopes to detect some of the test. So why we use that radioisotope? That means it is possible to detect radioactivity with conjunctive sensitivity, because normal isotopes, that is C12, that is common element that cannot be detected easily, but C13, C14, for example, it can be detected due to its high energy level and due to its radioactivity or due to its spontaneous emission. So it is possible to follow that after some times, because it having some self life period, so we can detect that thing how much time of the life is gone. So these possible trace elements also happen in individual atomic pathway, because we are always exposed to some radioisotopes. Then we can detect how much times. For one example of the radioisotope test is used by this geology student, or find out the age of a stone or age of a tree. एक ट्री है और एक स्टोन पड़ा हुआ है, कब बना हुआ है, कितने साल हो गया है, ये सब टेस्ट करने के लिए ये रेडियो आइसोटोपिक टेक्निक यूज होता है. So these are some techniques that can be used. The unit of radioactivity is obviously Curie. This original unit for measuring radioactivity is Curie, that is defined by the Madame Curie, and 1 gram of radium, that is 226, and more recently defined as 1 Curie equal to 3.7 into 10 to the power 10 radioactive decay per second. This is some units of the radioactivity in SI unit, that is called becquerel. 1 becquerel equal to 1 radioactive decay per second, equal to 2.7 into 10 to the power minus 11 Curie. So the main unit is Curie or becquerel. Detection measurement of radioactivity are the common method to detecting qualifying the radioactivity, and these are based on the ionization gases, extraction of solid, all these things. And this radioactivity to expose photographic emulsion, that is called autoradiography. if we are using this radioactivity technique to taking some photographic image or photographic test, that is called auto radio photography, auto radiography. What is auto radiography? Radiography is the visualization of the pattern of distribution of radiation. In general, radiation consists of X-ray, gamma ray, beta ray, all these things, and this medium in a photographic film. That means एक फिल्म है, उसके ऊपर कितना अल्फा बीटा गामा रे वहां से रेडिएट हो रहा है, वो एक स्क्रीन में उसका इमेज आ जाएगा. That can be called auto radiography. Is the specimen itself the radiation. So रेडियोग्राफी और ऑटो रेडियोग्राफी ये डिफरेंस है. रेडियोग्राफी मतलब हम लोग स्क्रीन में डिस्प्ले करेंगे, ऑटो रेडियोग्राफी मींस इटसेल्फ सैंपल खुद कितना निकला हुआ है उसको पता चलेगा. एंड दिस इज मेनली यूज्ड इन केस ऑफ डिटरमाइन द एज ऑफ एवरीथिंग. स्टोन हो गया, ट्री हो गया, उसका कितना साल हो गया, ये बोलते हैं 5 साल पुराना है, 500 साल पुराना है, ये 2000 साल पुराना है. हम बोलते हैं कि हाँ नहीं, ये इंडियन सिविलाइजेशन इतना साल. अभी मान लो कोई रेडियो आर्कियोलॉजी का साइट ओपन हुआ है, वहां पे कुछ मिट्टी का कुछ बर्तन मिला है, तो उसको टेस्ट करेंगे तो पता लगेगा हाँ नहीं ये तो 3000 साल पुराना है, मोहनजोदड़ो टाइम का है. ये सारे थिंग होता है ये ऑटो रेडियोग्राफी टेक्निक्स द्वारा. इसका डिटेल्स में नहीं जाना है. दिस इज ऑल अबाउट योर टेक्निक्स दैट कैन बी इम्यूनोग्राफी एंड रेडियो एक्टिविटी, आइसो रेडियोग्राफी टेक्निक. इसके नाम सुना था पहले ये सारी चीजें थोड़ा बहुत?
नहीं सर.
हाँ, ये ज्यादा आपका हमारा एनवायरमेंट लेबोरेटरी में ये सब नहीं होता है यूज. मैक्सिमम हमारा यूवी विजिबल और डबल एस, आईसीपीओएस, मास स्पेक्ट्रोस्कोपी थोड़ा एडवांस में जाएंगे तो, नहीं तो आईसीपीओएस भी सारे जो हैवी एलिमेंट्स रहता है, एलिमेंटल एनालिसिस, तो सारे में यूज होता है. बट जनरल लेबोरेटरी में आईसीपीओएस भी नहीं रहता है, अप टू यूवी विजिबल, आईआर, और रहता है तो डबल एस. बस इतना जो है बेसिक फंडामेंटल चीज है, ये आपको एज ए एनवायरमेंटल स्टूडेंट आपको जानना मतलब बहुत ही आवश्यक है. उसका ऑपरेशंस कैसे होता है, उसको वो कहाँ से यूज होता है, उसका प्रिंसिपल्स क्या है, ये सारी चीजें तो हम थ्योरी में तो पढ़ लिए कि उसका प्रिंसिपल्स क्या है, उसका कैसे दिखता है और कहाँ पे यूज होता है. बट हैंडलिंग ऑफ द इंस्ट्रूमेंट इज वेरी क्रूशियल पार्ट. तो ये आपको प्रैक्टिकल जहाँ पे करेंगे तभी पता चलेगा, मतलब आप एक्सपोजर होंगे इंस्ट्रूमेंट को. मतलब दैट मीन्स इफ यू आर डूइंग इन रिसर्च फील्ड और आपका इंडस्ट्री में है कहीं पे, तो विजिट करके जा सकते हैं, थोड़ा बहुत आइडिया हो जाता है. और कहीं एनवायरमेंटल लैब है तो वहाँ पे मस्ट होगा. ये तो होता ही है, मास स्पेक्ट्रोस्कोपी और डबल एस, ये सारे होता ही है. कभी ऐसे लैब में विजिट किए हैं?
नहीं.
और यूनिट 2 यूनिट 3 कंप्लीट हो गया. अभी यूनिट 4 में मेन एचपीएलसी क्रोमाटोग्राफी, दिस इज द मोस्ट इंपोर्टेंट टेक्निक, इलेक्ट्रोजेपिलिसिस. ठीक है, आज यहीं पे समाप्त करते हैं. नेक्स्ट
ठीक है
हम
सर.
लोग का अभी कंटिन्यूसली क्लास लेंगे, आपको दिक्कत तो नहीं है ना अभी?
नहीं नहीं कोई दिक्कत.
हाँ, क्योंकि जनवरी में ख़त्म करना है, तब जनवरी बोलता हूँ, दिसंबर और जनवरी फर्स्ट वीक में आपका एग्जाम स्टार्ट हो जाएगा 15 तारीख से जनवरी.
ओके सर. ओके.
तो अभी कंटिन्यूसली उसको ख़त्म कर देते हैं. इसे ये तो हो गया और ज़्यादा नहीं लगेगा इसमें. तो फर्स्ट यूनिट में क्या बचा है हमारा? यूनिट 2, 1 to 2 में एक क्लास में हो जाएगा, ये थोड़ा साइकिल वगैरह का, और 2 यूनिट बचा है, हो जाएगा 1 महीना. ठीक है, आप
ठीक है
इसको
सर.
डाउनलोड कीजिए, पढ़िए.
ओके सर.
ज़्यादा कुछ है नहीं इसमें, ज़्यादा टेक्निक्स के बारे में थोड़ा सा, जैसे कि वेरी मच नेसेसरी है उसको जानना, टेक्निक्स सारे एनालिटिकल टेक्निक्स। ओके, लेट्स
ओके
टॉक।
सर, ओके सर।
ठीक है, कुछ डाउट है
गुड
तो
नाइट
पूछ
सर।
सकते हैं, मतलब।
श्योर सर, श्योर।
हम्म
पूछ लो ऐसा कुछ होगा तो।
हम्म।
ठीक है।
ओके,
गुड
गुड
नाइट सर,
नाइट।
बाय।